Alright, it's time for the solutions for the basic matrix operations assignment. This is rather quick. On the first one, so you just have to list the dimensions. So this particular matrix has 2 rows, and it has 3 columns. And you can see it just like such, and you just write them just like that, 2 by 3. This next guy has 1, 2, 3 rows, and the columns number 2. So there's 2 columns, it's a 3 by 2. And this guy here only has 1 row, but it's got 3 columns, so it's a 1 by 3. Moving on to 4, if you want to add your matrices, you just add the corresponding pieces. So 4 plus negative 2 is going to give me 2. 5 plus negative 7 is going to give me negative 2. 4 plus 4 is going to give me 8. Negative 5 plus 5 is going to give me 0. So here's my entire matrix. Here, let me redraw that 8 so it looks a little bit better. So there you go. Moving on to the next one, if you want to subtract matrices, you just have to subtract the corresponding parts, the corresponding entries. So you take 15 minus 10, that gives you 5. 3 minus 7 gives you negative 4. Negative 2 minus 4 is negative 6. And 2 minus negative 3 is the same thing as 2 plus 3. So that gives us 5. And that's my resulting matrix. Moving on to 6, if you want to add matrices, you just add the corresponding parts. So I'm going to do negative 2 plus 4, which is 2. And I got 3 plus negative 5, that's going to give me negative 2. 5 plus negative 1 is going to give me 4. Negative 1 plus 3 is going to give me 2. 7 plus negative 7 is 0. And 0 plus negative 6 gives me negative 6. And there's my resulting matrix. On 7, you need to subtract the matrices, so make sure you're always subtracting all of these. We need to do 2 minus 5. That's going to give us negative 3. Negative 2 minus 3 is going to give us negative 5. 6 minus 1 is 5. Negative 4 minus 2 is going to give us negative 6. 3 minus 7 is going to give me negative 4. And then 8 minus 4 is going to give me 4. And that is my entire matrix. You subtract the corresponding parts. On 8, we are going to subtract these matrices. Again, make sure you subtract the corresponding parts. So subtracting the top left pieces, the first entries, you're going to get 9 minus negative 4. That's going to give you the same thing as 9 plus 4, which is 13. 6 minus 7 gives us negative 1. Negative 2 minus negative 5 is the same thing as negative 2 plus 5, which is 3. Negative 4 minus 3 is going to give us negative 7. 8 minus negative 4 is the same thing as 8 plus 4, that's 12. And negative 1 minus 6 is going to be negative 7. So here's my new matrix. Make sure it's a 3 by 2. On 9, we should have to add the corresponding pieces. So I'm going to take the first items and add them together. That's going to give us 5. 6 plus 7 is 13. Negative 4 plus 1 is negative 3. And moving down to the next row, 8 plus negative 8 is 0. Negative 9 plus negative 1 gives us negative 10. 0 plus negative 8 is negative 8. Negative 8 plus 6 is negative 2. Negative 7 plus 0 is negative 7. 7 plus 2 is 9. And that's the whole matrix. On these parts, we need to figure out what this hidden matrix is. So what pieces do I have to add to these to get my results over here? Well, 8 plus something equals 4. That something is going to be negative 4. Negative 2 plus some number is some number here is going to give me 5. That'd be 7. We need to get 7 more in there because negative 2 plus 7 is 5. 4 plus something is 7. that number would be 3. And then 5 plus this last piece is going to give us 6. That last piece would be 1. And so this is my matrix A. On 11, we're going to be subtracting the pieces. 2 minus what is going to give me a negative 4. That number would be 6. 6 minus what gives me 3. That's 3. 8 minus something gives me 2. That is also going to be 6. And then negative 5 minus something is going to give me 1. If you ever have if you have a number where you subtract and then you get something bigger, you have to subtract a negative number. So negative 5 minus negative 6 would get it up to 1. And that's my resulting matrix. Moving on to 12, on this one we start with a matrix that we don't quite know yet, but it's a 2 by 2, so I'm going to give me some little space here. 2 by 2, something minus negative 2 gives me 3. Well, minusing a negative 2 is the same thing as adding 2, so 1 plus 2 gives me the 3 I'm looking for. The next piece, something minus 9 is going to give me a negative 5. Well, if you take 4 and subtract 9, you'll get negative 5, so that's going to be 4. Something minus negative 1 gives me 9. Subtracting a negative 1 is the same thing as adding 1, so if you had just 8 and you add 1, you'll get that 9. And then the last piece, something minus 4 gives me 4. Well, that would be 8 as well, because 8 minus 4 is 4, and that's my whole answer. Moving on to 13, adding these two matrices, poor Heather got this as a sum. What error did Heather make, and what is the correct sum? Well, looking at this, I noticed that here the 2 plus the negative 2 gives 4, so that part's okay. But here we have 7 plus negative 6, that should give us 1, but that's not right there. It's actually right here. So it's looking like they kind of took what was in this first column and are getting this, the first row and getting this first column. But let's check the others. 2 plus 2, well, that should give you 4, not 1. So yeah, it's looking like the rows and columns are kind of messed up here. Negative 3 plus 3 should give you 0. Yeah, so it's looking like the rows are becoming the columns. And so that'd be the error with this one. She's switching the rows and columns on her result. So there we're out like that. She switched the rows and the columns. So like our first row became the first column, which is not what you do. If you start out with a row, you'll end with a row there just like that. Anyway, so if you're going to add these correctly, I'm going to just leave that up there and just write my result. 6 plus negative 2 gives us 4. 7 plus negative 6 gives us 1. 2 plus 2 gives us 4. And then 3 plus negative 3 plus 3 is 0. So that would be my correct solution there. Moving on to the last section there, we just need to do some scalar multiplication. You take this 3, the negative 3 out front, and times by everything that's inside. So really you have everything that's inside, and you just times by that negative 3 out front. So 3 times negative 3 gives us negative 9. 7 times negative 3 is negative 21. Negative 12 times negative 3 is positive 36. 5 times negative 3 gives us negative 15. Negative 2 times negative 3 gives us 6. And negative 4 times the negative 3 out front is going to give us positive 12. And that's the whole answer for 14. On 15, we actually only have one row, but you still can multiply by that number right out front. So that negative 2u times 6 is going to give me negative 12u. 5w squared times the 6 is going to give us 30w squared. The 3x minus 2 part times by the 6, you're going to still have it be 3x minus 2 times by the 6. So if you look at that, it looks like a distribution problem, and that's exactly what you need to do. You need to do 6 times that 3, which is 8. The 6 times the 3x, so it's going to be 18x, and then minus the 12 is going to give us our last term, and that's our final answer. Moving down to 16 and 17, you need to take everything that's inside this matrix here and times it by what's in front, the negative 4m. So 2m times negative 4m is going to give us negative 8m squared. The 3n squared times negative 4m is going to give us negative 12mn squared. The 5 times x to the third times the negative 4m is going to give us negative 20mx cubed, not squared, cubed. And then 2xy times the negative 4m is going to give us negative 8xy. And let's put the m part first. M, x, y. And that is my whole matrix. And then we just got our last one here. You're going to take each of these pieces and times by what's in front. So negative 2c times 5a cubed is going to give us negative 10a cubed c. And then negative a times 5a cubed is going to give us negative 5a to the fourth power, because a times a cubed is a to the fourth. And then 3x times the 5a cubed is going to give us 15a cubed x. And 3b to the fourth times 5a to the third is going to give us 15b to the fourth. Oh, let's do a's first. We'll do it alphabetical. A to the third, b to the fourth. And then negative 11y times 5a cubed is going to give us negative 55. Negative 55 a to the third times y, and then times by that 10, you're going to get 50 a to the third, and that is going to be the entire matrix right there. There we go. And I believe that's all the assignment, all in just 12 minutes.